Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hydrate formation, gemdiol formation, from a ketone with water is favored when the carbonyl carbon is more electrophilic, more susceptible to nucleophilic attack by water. The equilibrium constant K for hydrate formation increases as the carbonyl carbon becomes more electron deficient. Moving on to the next step. Identify the electronic effects of substituents on the carbonyl carbon in these alpha-tetralone, 3, 4, dihydronaphthalane 1 to H1 derivatives. The carbonyl is at C1 conjugated with the benzene ring. Substituents on the benzene ring affect the electrophilicity of the carbonyl carbon through resonance and inductive effects. Moving on to the next step. Compound ICH3O at position 6, para to the carbonyl relative to the ring. The methoxy group is electron donating by resonance, which donates electron density into the ring and toward the carbonyl, making the carbonyl less electrophilic. Lower K compound to H3CO at position 6, this appears to be the same substitution pattern as I, but drawn differently, ortho-meta position relative to carbonyl. Looking at the structures carefully, in ICH3O is at position 6, para to C1 carbonyl through the ring, and in 2H3CO is also at position 6 but on the other side. Both are electron-donating methoxy groups. Given the answer key lists I2, compound 2 has slightly less electron donation to the carbonyl than I, meaning the methoxy in 2 is meta to the carbonyl while in I, it is para. Paramethoxy donates more electron density to carbonyl than metamethoxy, resonance versus inductive only, so I has lower K than 2. Compound 3 no substituent unsubstituted alpha-tetralone. The carbonyl electrophilicity is intermediate. K is moderate. Compound 4O2N at position 6. The nitro group is strongly electron withdrawing by both resonance and induction. This makes the carbonyl carbon more electrophilic, greatly increasing K for hydrate formation. And for the final step. Order of increasing K, increasing electrophilicity of carbonyl. I, para OCH3, strongest electron donation to carbonyl lowest K, 2, meta OCH3, or ortho weaker electron donation slightly higher K than I. 3. No substituent, no electronic perturbation higher K than methoxy compounds. 4. Para no 2, strong electron withdrawal highest K. This gives I to 3, 4, which corresponds to option A. Option B places 4 lowest, contradicting the electron withdrawing effect of number 2. Option C places to lowest and I highest, which is inconsistent with methoxy being electron donating. Option D places 4 lowest, again contradicting number 2 electron withdrawal. Therefore, the correct answer is A. Therefore, the correct answer is option A.